Okay, hi student. So hopefully you are on the YouTube now. We are live together with the Fine Science 2 student and the others from Fine student. Hopefully today the lesson can be help you more. Today I just want to discuss about the last exercise that I passed to you. Okay, student, can you feedback me that mean you can listen me or not? Then you can see me or not? Okay, we want to make sure first. Okay, the student on the line, you can reply me. Okay, we wait the student to answer me. Yeah, you can listen me or not? Okay, how many is online? Okay, Jessica Hall, thank you. Okay, so I want to continue about the application because the day we stop at the liquid pressure, then the application we just cannot finish. Yeah, good afternoon, Sabrina. Okay, so now we continue with the application of the liquid pressure. Okay, let's see some of the diagram. Okay, let's see the application that's in our daily life. This all is happen in our daily life, but we not realize that one is a liquid pressure. Okay, let to see what is that. Okay, first one is the position of the water tank in your house. Okay, have you find it? Where's the location of this one water tank? Okay, normally we are put at the top, is it? Okay, we never put at the bottom. Okay, we put at the top, normally at the roof there. Okay, let's see what is that. Okay, this one is an example diagram. Okay, you see the tank of the top, they put at the top of the house. Okay, now we're going to explain why you want to put at the top. Okay, so from here, the water tank is usually they will place in the space between the ceiling and also the roof. Okay, okay, why we want to put at the top? This one is a reason. Okay, because we want to create a big different height. Okay, big different height between the water level and also the tank, and the water tap produce a high water pressure at the tap. So that means when the height is higher, so you find it the liquid pressure. Okay, remember the formula. Liquid pressure is a rho Hg. So important now we go to adjust the H. Okay, high CT. Okay, we go to adjust the H. When the H become higher, that means the whole system, the pressure should be higher. So from here, the water flow at the high speed when the tap is turned on. Okay, you can refer the diagram here. Okay, first one from the pump house, they pump all the water they keep in the reservoir. Okay, after reservoir they will flow. Okay, after that they keep in the water tower. Then water tower will pump again, go to your water tank for your house. Okay, normally you find it they flow from the higher to the lower until to your house the water tap. So from here that means the water tap later they come out the water should be in high pressure. Okay, if the water tank should be higher more, that means they can produce the pressure should be the higher because of the different bigger depth. Okay, we can say about the height lah. Okay, now we go to the second application. Okay, this is a position of the intravenous liquid. Okay, let's see the diagram here. The intravenous liquid bag normally we put at the top, okay, higher from your body because we need to let the liquid flow through your body, is it? So from here we got adjuster lah. Adjuster is normally they want to adjust the liquid, how fast they flow it. Okay, so from here we go to explain. Okay, a bag of the intravenous liquid is placed at the position higher than the body of the patient. Okay, normally it's higher than the body of the patient. Okay, reason. The reason should be the due to the difference of the height. Okay, of the liquid column that will push the intravenous liquid into the body of the patient. So the rate of flow of the intravenous liquid into patient body will still depends on the height of the bag, and also they will control by using the adjuster. Okay, this one is let the liquid flow in your body. Okay, number three about the construction of the dam. Okay, you can see the diagram. Okay, first one we go to one of the question they will ask. Dam is hold water at a high altitude. Explain why the wall at the base is thicker compared to the top. Okay, normally the wall you see at the bottom should be the thicker. At the height, the surface you find it less thicker. Reason is what? Because we know when the depth is increasing. Okay, water depth increasing, that means the pressure of the water at the bottom should be the highest compared to the surface. So that's why they need to create the dam should be thicker wall. They want to withstand the high pressure of the liquid. So from here we go to explain. Okay, the wall of the dam is built thicker at the base. Okay, thicker at the base because the water pressure is increases with the depth. Okay, when the depth just increase, that means at the bottom, the base must be highest pressure. So from here, the thicker section of the dam is able to withstand the high water pressure. Okay, so from here, the penstock, you can see the penstock, there's a here one tube, is at the lower section so that the high water pressure they will produce a fast flow of the water to drive the turbine. So later they will turn the turbine to generate the electricity. So this one is one of the question in the application question about 4 marks. They want you to explain using the liquid pressure. How come the construction of the dam apply the liquid pressure for this one situation? So you need to make sure you go to explain why upper part is thin, lower part become thicker. Then you must talking about the liquid pressure increase with the depth. Okay, so now we go to the last one. Okay, the last one is a use for the siphon. They're also talking about the pressure. Normally the pressure they flow from the high to the low. Now we go to C. Explain how the use of the siphon tube is work. How come they will work? Now we go and see the explanation. Okay, first one is a siphon is used to transfer. Okay, transfer the water from the higher level, go to the lower layer. So you can see this one diagram, they flow from the higher region, go through to the lower region. Now we go to explain. One end of the tube, okay, there's a fill with the water. Then we put inside to the tank at the higher position. Okay, another tube we put into the lower position. So this one tube we call it as a siphon tube. Okay, now the flow water. Okay, the flow water from and they will produce a region of lower pressure at the point B. Okay, the water sure be from the A they flow to the D, is it? But we compare A and also B. Sure, the pressure B is the lowest. Okay, that's why the atmospheric pressure can push the water in the tank, go through the A. Then the A can go to the B. Okay, if the B is high pressure, that means the water cannot go in the tube. Okay, the B must be low pressure first, then the atmospheric pressure push, then the water go in the part A, then go to the part B, then D sure is the lowest one. So from the B, they will flow until the lowest, go to the end of the D. So from here, they say atmospheric pressure pushes the water into the tube at the A. Okay, because of the low pressure of the B, then the atmospheric can be pushed. So finally, they will flow into the D lah. So this one is how come the siphon can be worked to transfer the liquid from the higher region to the lower region. Okay, so that one is four of the application. So hopefully can help you to answer the question of the application question, process question about 4 marks. So you need to explain A until Z. So that means you didn't means 4 mark, you can write one sentence and finish. Normally 4 mark is 4 point. You need to answer the whole process, how to function. Okay, now we go to the exercise for liquid pressure one. Today I got send you this question. So hopefully you finish. So today you can give me the answer. So if you not yet finish, you take out the paper. So we do together, then you give me the answer. Okay, prepare your calculator when I just ask, then you type your answer in the chat room. Okay, let's see here. Okay, first one, if the density of the water is 1,000, okay, they give you the density. What is the pressure due to the water at the bottom of the swimming pool? 2 meter deep. So they want water only. Pressure due to the water. So that means the question never talking about atmospheric. They're just water pressure. Okay, now the swimming pool, the deep is 2 meter. So anybody here can straightforward give me the answer of the pressure. Okay, pressure of the water. Okay, they're acting to the swimming pool, the base of the swimming pool about 2 meter deep. Okay, important what formula we need to use. Okay, remember this one. P equal rho Hg. This one is applied for the liquid pressure. So when you see the calculation, we make sure all the unit is the constant first. It's a SI unit, so we no need to convert. So from here, rho is 1,000. Then the deep is a 2 meter. Then we know, okay, if the question never mentioned gravitational is how many, we just take there's a 10. If they mention 9.81, so we need to use. Okay, so from here, the student, you can type here to show me what's your answer for question number 1. Okay, Ling Han give me the answer is a 1960 Pascal. Okay, the others, you can get the same answer or not? Okay, same as the Ling Han or not? 1960 Pascal. Okay, the others. Oh, Jessica, give me this the 200 to 20,000. Jessica, we need to find is a pressure, not density. Okay, we need to find is a pressure, not density. Okay, so Jessica, you help me to change your unit. Okay, yeah, Ling Han, we're using 10. The question never mentioned, so we're using 10. Okay, so the Pascal is, okay, Euro, they give me 20,000 Pascal. Okay, if you're still using the SI unit, then you need to convert lah. So this one is a Pascal. So from here, we're going to check the answer. Is it correct or not? Okay, yeah, correct. 20 Pascal. You also can write 20 kilo Pascal. Okay, depends for yours lah. Also can, both answer also can. Okay, then we need to go is a second question. This one is a simple question. We just apply only. Okay, second one, they're giving that the density of the mercury. Okay, they give you mercury density. Okay, now you need to calculate the pressure of the mercury. Okay, only pressure of the mercury acting at the point 40 cm from the mercury surface. Okay, this question also never touching about atmospheric pressure. They're just talking about the mercury pressure. Okay, acting to the point 40 cm from the mercury surface. So they want to find is a pressure. So can you find for me? Okay, important, I just remind you, SI unit. Okay, because you see the point, there's a 40 cm. Okay, how to convert 40 cm become meter first. Okay, then we do the calculation, then we find what is the pressure. Okay, now we wait the student to give me the answer. Okay, any response? Okay, the question never mentioned about the gravitational, so we're still using 10. Okay, so we're going to check. Formula is the same. We're still using the same formula to apply the pressure. Okay, Yuanru give me the answer is a 54,400 Pascal. Okay, we're going to check the others. Okay, Yiru also same. Wong Kai Xian also same. Okay, now we're going to print the answer from the Yuanru. We're going to check is it correct or not. Okay, we're using this formula. Help me to convert 40 cm becomes 0.4 meter already. Okay, then we're going to find out. Yeah, the answer is exactly correct. Okay, 54,400. Yeah, city also correct. Kaixin also correct. Euro also correct. Okay, then these two is a simple question. Then we continue to the third one. Okay, third one got diagram. Okay, nice diagram they show about the two fishes in the water. The density of the water is a 1,025 kilogram per meter cube. The surface area of the fish A is a 300 cm square. Okay, and the surface area, another one for the fish B, there's a 2,000 cm square. Okay, gravitational. Okay, now the question provided 9.81. And also extra one thing, there's a atmospheric pressure. Okay, they give you atmospheric pressure, 100 kilopascal. So that means later we need to use lah all the info they give you. Okay, first one we go to answer the question. The pressure exerted by water. Okay, the question they just want water. So you read very carefully, yeah. Okay, just now got atmospheric, is it? But this one they say the pressure exerted by water only on the fish A. Okay, so I want to answer from you, fish A. How many water pressure acting to the fish A? Okay, so we're still using the same thing. The formula just exactly the same. Just you help me to change about the density and also about the gravitational. Okay, so we go to see the answer from the student. Okay, for the fish A. Okay, city give me this 30,165.75 pascal. Okay, we're going to check. The others, is it our answer is the same? Okay, got other response? Okay, only city. Okay, we're going to see the others. We're waiting. Okay, no others. Okay, we just apply the same thing. The formula is the same one. Okay, Sabrina, give me this 20,110.5 pascal. Okay, we're going to see. So we're going to check is it correct or not. Okay, we're going to pin the answer from city first. We're going to check. Okay, it's the same thing. Okay, we're using it's the same thing. Okay, we got different answer. From here, Yuan Ru and also Yi Ru also give the different answer. We're going to check. Okay, 1025. Okay, 1025. Okay, the H. Okay, the H is a 2 meter, is it? So meter, okay lah, no need to change. Okay, 9.81. So we go to find the answer. The answer, city, we get the wrong thing. Yuan Ru also same, wrong. Okay, the answer from Sabrina and also the Yi Ru, that's correct. Okay, 20,110.5 pascal. Okay, what's the wrong thing? Okay, Yuan Ru, what's the wrong thing? Maybe you're using the 10, is it? Okay, you're using the different, gravitational is a 10, is it? So from here, we're using 9.81 if the question they give you. Okay, so from here, this one is the answer. Okay, now we continue with the B. The pressure exerted by the water also on the fish B. Okay, on the fish B. Okay, what do you think about that? Okay, I want the pressure now on the fish B. Just now is A, is it? Now go to B. Okay, your answer is, got any changes or not? Acting to the A and acting to the B. Okay, the surface area different. Got any changes? Okay, the others. Haisin can answer. Got any changes or not? Now the pressure of the water acting to the fish B. Okay, you will give me the answer is the same, is it? Actually, that's the same because same level should be the same pressure. Okay, the level same, the pressure is the same, but the surface area is not related. Totally not related. So the answer still the same. Okay, 20,110.5 pascal. Okay, now we go and find another one. Okay, here got explanation. Okay, pressure exerted on the both fishes is the same. Okay, pressure causes by the liquid that's not affected by the size or the shape of the object. So if the level is the same, everything the pressure should be the equal. Okay, so we don't care about the size, don't care about the area. Okay, then we go to the C. Okay, the C. They ask about the force. Okay, the force exerted by the water on the fish A. Okay, when they're talking about the force, so we need to recall back. What formula is related with the force and also pressure? Okay, so one thing we learned before, the pressure equal F over A. Okay, pressure equal force over area. Now I want to find the force, so that means your answer should be P multiplied with the area. So from here, the first information we know the surface area of the fish A. Okay, we label as a A1. That's a 300 cm square. Okay, can you see this one is a cm? Okay, I want you all go to convert become the meter. Okay, how to convert become the meter? You divide by 100 and divide by 100. You need to divide by twice because there's a square. Okay, if cm go meter, you just divide by 100 only, is it? But now we got square, so you need to divide by 100 and divide by 100. So that means you divide by 10,000 lah. So after divide, we get it 0.03 meter square. So this one is a surface area of the fish A. Okay, now we need to find the force exerted by the liquid pressure. So the formula is F equal PA. Okay, because the formula for the pressure is F over A. If I want to find force, so P multiply with the surface area. So from here, the student, can you give me the answer for the force acting to the fish A? Okay, I already show all the things. The pressure already is just now we calculate, is it? So we take that pressure. Okay, then after that, the area we convert already. We convert becomes 0.03. So your answer for the force is okay. From the zero, the answer is a 603. So yeah, 603 after that 3.15. Okay, the others. Okay, 603. The others. Okay, only zero answer. Okay, the others where to go? Okay, so we're going to check. Hurry up, hurry up. The others can try. Okay, we do know correct or not. Okay, Sharon. Sharon also give the same answer. Okay, we go to find out. Yeah, correct. The answer is 603.32. Okay, so normally the behind one you go to round number lah. Okay, 603.32 Newton. Newton, the force is a Newton. Okay, then we continue to the second one. Second one, they ask about the B. Okay, so I don't want to show anything. So you give me the answer. Okay, they ask about the B. Same like the method, same like the A, but now they convert is a fish B. So if using the B, that means you need to using this area lah. Okay, the surface area is a 2000 cm square. Help me to convert cm square become meter square. Okay, I want to answer B. Okay, fish B. What's the force acting on the fish B? Okay, we're going to try the others. Can answer or not? Okay, try your best. Okay, many students not enter the class today. Just got 28 watching now. Okay, anybody can answer me? The force exerted by the water on the fish B. Okay, 4022.1 Newton. Okay, Java also same. Okay, now we're going to check. Okay, surface area for the B now become 2000 cm square. I convert become meter square, becomes 0.2. Okay, now I continue using the same formula. Okay, Sikajing also same. Yenru also same. Okay, now we're going to check. Okay, the final answer is 4022.1 Newton. That's correct. Okay, thank you for the student. Jessica also correct. Okay, then we continue to the, okay, E. Okay, calculate the actual pressure. Can you see the keyword actual pressure? What's the meaning for the actual pressure? Actual pressure means you need to add about the atmospheric pressure. We call actual pressure. So from here you can see the diagram. Now they want actual pressure for the fish A. Okay, before that we calculate already. The water pressure for the fish A is how many? This one should be the answer. 20,000, 10 and point 0.5. Okay, but now they want actual. Actual means outside. Outside still got atmospheric pressure to acting, is it? So from here, we need to add atmospheric pressure. Okay, actual pressure acting on the fish A, the same like this one equation. Actual pressure equal to the rho Hg from the water plus about atmospheric pressure. So from here, we need to show, excuse me. Okay, just now answer. Okay, the pressure from the water plus this one is the atmospheric pressure. So you can see this one is 100 kilo. Help me to change about a kilo. I want Pascal only, I don't want kilo. So final answer, anybody can answer me. So sorry, I drink water a while. So anybody? Okay, I show everything already. Just about the pressure acting on the fish. Another one should be the atmospheric pressure. So when you see the question, must be very be careful. When they're talking about the actual pressure, means everything. Okay, Kai-Sien, give me the answer already. Okay, we just plus only, is it? So we're going to check, is it correct or not? Okay, this one should be the answer. Yeah, Ling Han, you can change become kilo also can. Okay, you can write the full using Pascal also can. Okay, should be the same answer. Okay, if you write kilo, so you don't need to write so many things lah. 120.1, then kilo Pascal, that's all. Okay, so CT also correct. Okay, so this one just only question 3. Then we continue to the question number 4. Okay, question 4. Okay, correct, Sharon. Okay, now we go to question number 4. Question number 4 about the cross section area, the sea near to the seaside. Find the difference of the pressure between the point A and point B. Okay, they want different. A and B. Different pressure. So the density given. Okay, but the question never provided gravitational. So we just using 10 only lah. Okay. So from here we need to find the differences. So that means you need to find what's the pressure at the A, what's the pressure at the B, then we go to minus lah. That one we call differences. So another method you can straightforward to difference the depth first. You straightforward take the 3 meter minus 0.5 0.8 meter, then you're using the rho hg to calculate what is the pressure. Okay, so because of the rho is the same, the g also is the same, just different of the height only. So you go to minus the height, then after that you can do the calculation. Okay, first one we're going to show what's the difference. Okay, different water depth 3 minus 0.8 we find it, there's a 2.2 meter. Okay, so from here, can you straightforward give me the answer for pressure? Different pressure, A and B. Okay, different pressure, A and B. Okay, I give you the height already. Okay, the depth already is a difference. So we straightforward to take 2.2 is a H lah. Then the rho, okay, question provided. The rho of the seawater. Okay, city give me the 23,100 Pascal. Okay, go and find the others. Okay, also correct. Okay, now we go to pin the answer first. Okay, check. So formula, pressure difference equal to the rho Hg. So if you apply all the thing lah, 2.2 multiply with the 1050, then 10. So the answer is correct. Okay, 2.31 kilopascal also correct. Okay, so from here, uh, 2.31 kilopascal, I think a little bit problem, is it? 23.1 kilopascal, that's correct. Yeah. Ning the bottom one should be correct. 23.1 kilopascal. Okay, so Sharon also correct. Okay, then we find another one. Okay, now we're going to see the U-tube. Okay, the U-tube going to measure the density. Okay, now the figure they show about the U-tube filled with the water of the liquid P. Okay, now we got water and also liquid P. in the soluble in the water. So given that the density of the water is 1,000, find the density of the liquid P. Okay, for this one situation, we need to find out the same level, same pressure. Okay, where you need to draw the line, you need to find the liquid and water when there's a differences. Okay, when they just separate by the two layer, okay, the layer, so we go to draw the line. So we cannot draw the line at the top. Okay, draw the line to the top here is nothing. So we're going to find out this one is the water, this one is a liquid P. Okay, when they just start to separate, so we draw one straight line. So this point, okay, and another point should be the same pressure because same level. So if we're talking about pressure, you must look above, don't go down already, above. So this one above, we got what? We got water pressure. Okay, how many water pressure? 10 cm. Okay, above again, we got what? Atmospheric. Okay, because the tube is open. Okay, now we go another side. Okay, this one above, we got what pressure? There's a liquid P pressure. How many? 12 cm. Okay, after that above we still got atmospheric, yes or no? Okay, but now we know this level and this level should be equal. So when you put the formula must be rho Hg equal rho Hg, is it? Actually, the both side, the atmospheric pressure, we can cancel. Because this side atmospheric pressure and the another side atmospheric pressure should be the equal thing. Okay, so now we go and show the formula first. Okay, this one is an info. H1 is 100 cm, H2 is a 12 cm. Both are also using cm. Later we just cut only, no need to convert. Okay, density of water is 1,000. Okay, but the density of the liquid P we do know. Okay, now I go to show. H1 row 1 equal H2 row 2. The G where to go? G we can cancel each other. Because when you put row Hg, this one also row Hg, G should be the same one. So we cancel each other. So now we left this formula. Okay, then we continue, put all the thing in. Okay, H1 is a 10 cm. Okay, both sides also using cm, so never mind, we no need to change. So another side should be 12 cm, is it? So this one is a row 2, this one is a row 1,000. Okay, so from here, can you understand how to find the row 2 or not? Say, the row 2 is stand for the density of the liquid P. Okay, so you give me the answer for the row 2. What is that? Okay, just a simple only. So the next round, I don't want to show calculation already. So you show me the answer. So the first round, I show you how to do the calculation like this. Okay, you must know, when they show about the YouTube, the citation, they want to find density. So the citation must do like that. Okay, 833.33. Okay, 3 person give me answer already. Sabrina, Siti, and also Jessica. Yiru also same. Yahweh also same. Okay, so we go and find the answer. Okay, sorry, got the pin wrong already. Okay, my part still not yet come out the answer. I just see there got 5 or 6 student answer already. Okay, come, I show. Okay, Sabrina Tang the answer. The other also same. Okay, the other also same. Just the unit, okay, unit also correct because they asked about the density. Kilogram per meter cube. So we're going to show the calculation. Okay, the answer is 833 kilogram per meter cube. Okay, I think every student also understand about this one. Okay, that's a no problem. Then we continue to the next question 7. Okay, this one is the same thing. So from here, the diagram they show about the test tube. There's a X and also a Y, which are not maximal. Now we go the density of the liquid X and also the Y. Okay, they give you density. Density for the X is 1,200. For the Y, that's 800. Okay, find the value of the H. Okay, atmospheric pressure, ignore because both sides is open, so we just cancel. Another thing you cancel because there's a G. Gravitational, that can be cancelled. Okay, now I want to find is a height. Okay, your height later your answer also in cm. Okay, same like the liquid X. So from here, I want you give me the answer. Okay, I don't want to show any calculation already because I know you understand. Okay, so we just wait the student to answer me. What is the H for the liquid Y? Okay. So I think student, there's a no problem, is it? Okay, Sabrina, straightforward, they give me 15 cm already. Okay. The others we check. Sure, it's more than 10, is it? You see the diagram, you know already. Okay. Okay, many of you answer already. Okay, City. Then the Yiru, Sikajin also give me, there's a 15 cm. Okay, we go to chat. Okay, I show the info. Okay, every time when you do the question, you must show the info first because you more detailed. Okay, when you do the calculation, you are more detailed. Okay, after that, we show the H1, row 1, H2, row 2. Okay, then we go to continue. Put all the info. Okay, H1 is a 10 cm. Then the row 1 is 1,200. Then the H2 we do know. Okay, we just empty first. Then 800. So from here we do the calculation. So we find the H2 15 cm. Okay, correct. Conclude all the student to answer it. Okay, 15 cm. When you see the diagram, sure it's more than 10 one, but we do know more how many lah. If you get the answer is a 9 cm, that means you get wrong already. Sure you wrong. Because this one already 10, how come you become 9, is it? Okay, so we continue to the question number 8. Okay, question number 8, the figure they show about the cross section of a dam. Okay, density of the water in the dam is 1,000. Calculate the pressure exerted by the water at the X. Okay, okay. After that, they say atmospheric pressure. Okay, that's 100 kilopascal. So calculate the pressure exerted by the water. Okay, by the water. So the question they say by the water only. Okay, they never say by the atmospheric pressure. So we just answer lah if they say by the water. Okay, so from here I just wait your answer. Okay, the pressure exerted by water at the X. So okay, we just take the calculation. I also don't know I got at the atmospheric or not lah. So the question they say by the water, so just ignore the atmospheric pressure unless they ask about the actual pressure. Okay, the question never mention about the gravitational, so we take that as a 10. Okay, unless they mention 9.81. So what's your answer? Okay, I think this one no problem, is it? Just a simple question only. Okay, exerted by water at the X. Okay, 40K. Okay, 40K. You see, I also do wrong because they say by water. So be careful. You see this one question, I also do wrong already. They say calculate the pressure exerted by the water. Okay, so this one is not related, by water only. So from here, I need to do the correction. So you wait me a while. I'm going to change first. I'm going to do some correction. So this one ignore. Okay, no more 10,000. Okay, this one ignore first. Okay, so I'm going to show again. Okay, we just ignore. Okay, because they say say the pressure exerted by the water at the X. So important when the question just say by the water, that means only water. If they say actual pressure, that one you need to add about the atmospheric pressure. Okay, Yanru. So read the question carefully. Yeah, just now I also do the mistake. Calculate the pressure exerted by the water. Okay, only the water at the X. So that means we no need to care about atmospheric. Okay, help me to cancel the atmospheric. Okay, not related like atmospheric is out. Okay, so we just using the pressure of the water only. That means 4 meter multiply with the density and also the gravitational, there's a 10. So the answer is 40,000 pascal hilang already. Okay, here 40,000 pascal. Okay, so you help me to change. Okay, unless the question they say actual pressure, so that means you need to add the atmospheric. So that means this one question they give extra lah. Suppose you need to understand the question. Okay, so we go to the next part. Okay, again. Question 9. Okay, we do some comparison first. Compare the pressure A with the pressure B. Okay, you give me the answer. Which one bigger? Okay, B or A? We do the comparison. Okay, we're going to find the depth lah, is it? So A and also the B, which one the pressure should be the highest? Okay, we just type there. Okay, you just type A highest or your B highest, like this enough already. Or you want to give me the symbol also can lah. Okay, we do the comparison for the pressure A and also pressure B. Okay, pressure A and also pressure B. So we got answer or not from the student? Okay, pressure A and also pressure B. Nobody. Okay, what happened? This one just a simple question. Okay, B is highest than the A. Okay, from Sabina. Okay, correct. Okay, the pressure B is higher than the A. Okay, Kai correct. B is higher. Okay, another one. Compare the pressure at the B with the pressure at the D. Okay, B is bigger than the pressure A. Okay, then now B, I want to compare B and donkey. Okay, B and donkey. How about the pressure? B bigger or D bigger? Okay, which one should be bigger? Okay, when find the student can answer it or not. Can answer it, that means you understand already what is the characteristic of the liquid pressure. Okay, B is bigger or D is a bigger? Yeah. Okay, Esther answer me already. Same. Okay, we don't have anybody bigger because the level should be the same. So the answer same. Okay, both pressure should be the same. How come the B I write the wrong thing? Sorry, this one should be the C, is it? Alamak. Okay, B is here. This one is B. Okay. Sorry. The pressure B and donkey, is it? B and donkey should be the equal. So you have me to do some correction, Ayo, you see the typing also wrong already. Okay, B equal to the D. Okay, compare the pressure A and C. A also equal to the C. Okay, understand? So important you know the level deeper. So the liquid should be the higher pressure. So I do some correction. So maybe later they see, find out why this one wrong. Okay, we do some correction first. This one should be the B equal to the, sorry, what is that? Okay, this one should be equal to the D. Okay, D, capital D. Okay. Okay, then we go back. Okay, this one is the correct answer. B equal D. C also A equals C. Okay, after comparison, we can see the question. Calculation. Calculate the pressure at B due to the water only. Density of the water is 1,000. Okay, the question also never mentioned about the G. So we take the G is a 10. So you calculate for me. I want the pressure exert on the B only due to the water pressure. Okay, so you can start to press your calculator to find for me what's the pressure acting on the B. Okay, what is the pressure acting on the point B? Okay, just due to the water only. Okay, 20 kilo pascal. Okay, block of the flats. Now the water they flow to the each unit of the flat is due to the water pressure. Okay, now a water tank, the height is a 3 meter. Okay, 3 meter is fully filled with the water. Now calculate the water pressure at the base of the water tank. Density of the water is 1,000. So they just want to find the water pressure at the base of the water tank. Okay, so gravitational they will provide. So we're just using 10. So you show me what's the pressure at the base of the water tank. Okay, base of the water tank, what is the pressure? Also, it's a simple question, same like just now. We just apply only. So important you know read the question. When you read the question carefully, then you know how to answer. Okay, so the water tank base, we got how many pressure exert on it. Okay, so we're going to find out the student can answer or not. Okay, only the simple question. Okay, Yuanru give me 30K, is it? 30,000 pascal. Okay, just a simple lah because 3 meter only, no need to convert everything. Yeah, Nixon suddenly appear already. Okay, so the Nixon answer also same. Okay, remember Nixon PA, the P is a capital letter, not small letter, Pascal, Okay, so we go to answer. Okay, there's a 30,000 pascal. Okay, so we continue to the B. Based on the diagram, can you compare the water pressure at the P and Q? P and Q. Which one pressure should be higher? Okay, so you give me the answer. P and Q. Which one produce a bigger water pressure? So that means when you just open the water tap. So the pressure when the water to flow out, which one produce the highest pressure to flow out? Okay, we're going to check P and also Q. Which one can produce more pressure? Can let the water flow out very fast one, high speed. Okay, which one? Okay, this one no calculation is it? Very fast only. Just tap there, then you show me the answer. Okay, P and Q. Which one produce the highest pressure? Okay, Q. Okay, Sabrina, give me the answer. There's a Q. Sharon also Q. So we got to find out. I know there's a Q. Then you need to answer, is it? Q is higher than the P, Esther. Okay, give me the answer. Why? Explain your answer. Why you know the Q should be the higher? How you know? So we need to explain. We not just only answer which one should be the higher. So we need to answer some more. Okay, so please help to answer. Okay, if you say Q should be the higher, then you give the reason. Why you choose the Q should be the higher? Which one is a key point? Which word is a key word to make you to consider the Q should be the highest? Okay, yeah, Yiru, Q is higher than P. Reason? Okay, how you know? Because we see about what? Okay, density here is not related already because both also is a water, is it? Gravitational also not related already. Important is a okay, the height of the Q is higher than the P. Yeah. Okay, Shikayi, yes, that's correct. About the height. Okay, the different height is the biggest. So from here we go to answer. Okay, Q is higher than P because the depth of the water level. Okay, you can say the height, okay, from the water tank until to the Q, the water tap of the Q. So from here they say the depth of the level for the Q is greater than the P. So that's why the Q pressure is higher than the P pressure. Okay, so this one is how to answer the question. When you choose, you need to explain. Okay, Okay, so our question is until 9 only. So today the task you need to do that is okay, formative 2.1. Okay, about the three question only. Okay, you do inside your exercise book, copy the question and answer it. Okay, one more thing is sorry, you need to key in the Google form. The Google form I share already there. They got 10 of the question, objective question, you need to answer it. And also today the lesson code. Okay, today the lesson code. Anybody here faster one? You have me to type here. Okay, Yiru still answer. The pressure in the liquid is increases as the depth of the water tank also increases. Yiru, you must compare about the Q and P first. You need to mention either one. So you say the pressure in the liquid increases at the Q as the depth of the Q of the water tank in the Q is higher than the P. So you add the word P and Q inside the sentence. Then you are correct. Okay. So from here, this one is a task today. Okay, today you got code because you need to answer the Google form. So the code today is a liquid. Capital letter, liquid. No hashtag. You don't type hashtag. So you type liquid, liquid, no S. Liquid only. liquid underscore 2021. Okay, anybody here can help me to type? Okay, can help me to type the code, today code. Okay, capital letter, capital letter, see anybody can help me to type, liquid. After that, you need to type underscore, then 2021. Don't copy here. Okay, straightforward, you type there. Maybe you copy here, they got mistake, they got spacing. Okay, so understand, so inside got 10 of the question, you need to complete it. That one is about the liquid pressure. Okay, so thank you for the student to type for me. So this one you need to type again in your Google form as today code and also 10 question. Okay, so let's see got anything or not. So today the lesson we just until here only lah. So the next one should be the Thursday. Okay, Thursday I will go through your class. Okay, so from here, thank you for your watching. So and thank you for the student to answer me the question. Hope you mark you mark your paper. Okay, after that you do some correction. Okay, so today our lesson just until here only lah. So for the student, if you still do not understand, so you can PM me to ask about this one how to do. Okay, thank you. Okay, thank you everyone.